Hello, everyone, and welcome to our session. My name is Tyler. I am head of product here at 3num, and we are also joined today by our CEO and founder, Chris. So, wanted to thank everybody for joining. We're super excited to get a chance to talk a little bit about kind of what we're building. And before we jump into things, just wanted to give a quick kind of overview about who we are and sort of what we're doing here with respect to 3num. So, Chris, I'll just give his quick introduction before he takes over here in a little bit. But Chris is the CEO and founder of 3num. He's been in the security space for quite some time now, building cryptography-based security products, going back to early firewall VPNs at a company called WatchGuard, as well as he was the co-founder of a company called Napera Networks. For myself, I've been working in the Web3 space since 2016. I actually was the chief operating officer for a Web3 identity company that Chris had started at that time. So I really cut my teeth sort of within the decentralized identity space, working with Chris and others, really helping pioneer some of those initial W3C DID specs. And most recently, I've been very actively involved in the Deepin space. I had started the first Deepin podcast. We've had projects like Helium and some other great companies on. So that's just a little bit about kind of who we are, where we're at within the 3num world. So we're going to go over three things today that we're pretty excited to get a chance to share with you. The first thing is we'll do a quick overview of 3num, really what our protocol is, this concept of on-chain mobile numbers that we've developed. We're going to go through a quick product demo and showcase some of the features and functionality and things that users can expect as the benefit of really transitioning telephony into this Web3 world. And then Chris is going to show a CCIP number lookup demo and kind of walk through the architecture for those who are interested in learning a little bit about how that works. So let's jump right into things. And I think the best place to start is providing kind of an overview of what the 3num protocol really does. And so in a nutshell, we are bringing telephony on chain. So we sort of pioneered this concept of a Web3 mobile number, which is really our way of transitioning or transforming sort of the world's most ubiquitous communications identifier into a on-chain sort of Web3 first world, really unlocking this new paradigm for both telephony companies and users alike. And so at a really high level, what it starts with is sort of this unique and novel innovation that we created around transforming these mobile numbers into on-chain identifiers. With our protocol, we're able to continue the compatibility with existing SMS and voice and traditional phone numbers. From there, we're really able to leverage this sort of crypto first environment for doing crypto communications, which unlocks so many new opportunities and things that just don't exist with our current world. And really at a super high level, we're able to bring benefits that Web3 and blockchain can enable directly to where customers are already using them with their phone number and their sort of existing world that they know. So, one of the questions that we get a lot is sort of what is the benefit or the value proposition of actually transforming mobile numbers into these on-chain identifiers. When we were cutting our teeth back in the decentralized identity days, one of the things that became really apparent is that there's three ubiquitous identifiers used across the world: phone numbers, email addresses, and social logins like Google and Facebook. And while phone numbers are incredibly prominent, there's still a lot of challenges and a lot of problems that somewhat come with them. And so as we transition these mobile numbers into a on-chain identifier that users can use to communicate with one another, we can unlock a whole new world of these incredible benefits. Things like unparalleled spam prevention, being able to cut out those annoying SMS and voice calls that you can't just do in the normal world today. There's things like not being able to allow caller ID spoofing by having cryptographically secure, authenticated endpoints that are communicating with one another. We're able to bring benefits like your phone number is your wallet. You're able to send crypto directly between users and you don't need to rely on other apps. You can just do it directly through the protocol, and other things that really are a benefit for users. So that's a bit of a high level of what we're building on the 3num protocol side. As a company, we are building the protocol really with the intentionality of having other builders and telephony customers implement what we're doing within their ecosystem. But we are currently taking sort of a hybrid approach where we have a app called Speak Easy. And this is a second phone number app that's powered by the Threonum protocol. And so I actually want to start by giving you a demo of that, because a lot of those benefits that are unlocked at the protocol layer, we're sort of delivering to users and customers via this application layer. So with that, I'm going to turn to being able to show you a quick demo. And this is going to be a way for me to showcase what it's like to get onboarded, at least with respect to our app, show you a few of the features and functionality, and then I'm going to go into a couple other of those really novel applications, things like spam prevention, things like sending crypto directly to users here in a moment. But I've got my Speak Easy app pulled up. And again, this is our app running on the Threonum protocol to really show what's possible. But I'm going to click Get Started here, and I'm going to go and create my mobile number. So I'm actually locally based in Austin, Texas, so I'm going to choose a 512 area code. That's what we have in the Austin area. And our service right now is going out. It's getting a traditional mobile number, and right now what it's going to do is it's actually going to transform this into a on-chain mobile number. Now, in the Threonum world, we have on-chain and off-chain numbers. So an on-chain number is one that actually gets minted to an L1. And in this case, this is actually going to be an off-chain number using CCIP. So here I've got my number, and after I click continue, it's going to give me a couple plan options. I actually have a promo code, so I'm going to skip this. I'm going to paste a code in here that will be used. So now what's happened is I have essentially paid for and turned that number into a on-chain mobile number. And Chris is going to go through a few of the architecture and sort of how this all works behind the scenes here in a little bit. But I really want to show you a couple of these other awesome things with our onboarding. So from here, we allow users to claim a Web3 username. So I'm going to do, let's try Tyler demo. Now, right now we're using ENS, but obviously with projects like Avi Domains on Avalanche, we actually support Avi Domains as well. And it's very, very comparable. But I'm going to go ahead and click continue. It looks like this username is good. And so what's amazing about this now is that when I'm going to communicate with contacts or with other users that are sort of in this new network and ecosystem, they actually will see my Web3 username that shows up when we're communicating. There's some other really cool things, like this will actually show up as part of my outbound caller ID when calling regular phone numbers as well. But for the sake of this, we'll just kind of continue on. I'm going to do enable contacts so that I can begin communicating with folks who are already in my address book. And from here, you can see that I have actually been able to get right into the app. So we've got chat and voice, typically exactly what you'd expect. I can actually enable this feature real quick so we can try out some voice here in a moment. But I'm going to send a quick message to one of my friends. And I'm actually going to start by sending something to austincrypto.speakeasy.id. And you can see now that I actually have them in my contact book. So I'll swipe down to get rid of the seed phrase management. By the way, one of the things that's really unique about our approach, this is more at the application layer, but when it comes to actually developing the way that users interact with this, you can use embedded wallets and you can use external wallets to be able to do that. It's really up to sort of the deployer's choice and frankly what users are going to be requesting. So in our case, we're using embedded wallets with here. You can use an external wallet as well for the sake of Speakeasy, excuse me. But I'm going to just say, hello there, great to connect. And I send that message, and you can see that there's the wallet address that's associated with it, and there we go. So he and I have actually just started a conversation. They can send me a message back, and that is all well and great. So I'm going to now go and send a message to my wife, and let's see here. I've got her in my contacts book. So when I go to send her a message, I'm going to say, hello, this is my new Speakeasy account with my Threonum on-chain mobile number. Love you. And I'm going to send that to her. And so right now, this message has gone over the existing SMS network, right? She's able to get the communications directly via the SMS protocol, whereas the message that I sent to this on-chain number actually used our Threonum protocol to deliver that communication. Why that's important is because there are a lot of novel things that we're able to do at the protocol level where you just don't get that with SMS. Now, we're able to build a lot of that phenomenal functionality sort of at the app layer, but for the sake of this, I just want to be able to showcase exactly how easy it is for users to get a number. And if I go into my settings real quick, you can see there's my number, there's my wallet address that was generated, and I'm communicating with folks as if I was doing already. And it's all powered by the Threnum protocol. So that is a quick demo of what we have going on the Speakeasy app. Another amazing thing is, when it comes to doing voice, we're able to do two-way calling between other on-chain numbers via the Threnum protocol, as well as regular phone numbers as well. But regardless, when you're calling both of them, you're able to have your Speakeasy username show up as your outbound caller ID, which is really pretty cool. It brings a personal level of communications. There's a few other benefits that we're going to get into with things like, preventing caller ID spoofing, because numbers are authenticated against the wallet address, so it's impossible to spoof with the Threnum protocol. But those are just a couple of the really amazing things that we have with the Speakeasy app that's powered by the Threnum protocol. And again, a developer or a telco company is able to integrate that directly into their service with existing users and be able to deliver a lot of those benefits that are actually enabled by the protocol. So that's a quick demo of how we began communicating. And one of the things that I talked about that is really a unique benefit when we're transitioning these users into a sort of a Web3 first world are unlocking benefits that weren't possible before. A couple of the big ones that we hear a lot from telcos, as well as just customers, is spam prevention. People are super tired of getting calls and SMS messages from numbers that they don't know, from people that are maybe spoofing numbers to do fraudulent activity, so on and so forth. And so as we transition users into this Web3 first world, we're able to deploy a new set of spam prevention techniques that you just don't get within that legacy space. So I'm going to show you a demo here in a moment of how that kind of works. But a few of the things that are really kind of unique and novel to this Web3 first ecosystem are things like stake to contact. So you can require inbound callers to basically put up some crypto before having a inbound call that actually gets to your phone. The other thing is that you can require users to have a Web3 username. That could be an Avi domain, that could be an ENS. You can also do things like ensure that they have a minimum wallet balance. A lot of times when there's telephony fraud going on, these hackers or spammers or whatnot will basically just generate a bunch of numbers. And so it becomes fairly low cost to send out a bunch of spam messages across the network, to be able to send a lot of calls across the network and do all of these things that are generally not so great. And so one of the things that we're able to do now is that we're able to set requirements like, I need to ensure that a user contacting me has some minimum wallet balance, whether that be $10 or $20 of crypto essentially in their wallet that's tied to their phone number before making a call. There's other things that we can leverage. This is a little bit more kind of in the crypto woods, if you will, but we can also require that if you want a user to contact you, for example, they have to have comparable on-chain attributes. So just to give you a quick example of that, if I have an NFT that's owned in a community, I could essentially say, anyone that owns a NFT in that community is able to contact me. And again, this is really the power of what happens when we transition these mobile numbers into being a crypto native asset or identifier that can be used. There's a few other things. A lot of those are related to voice calls. We're able to do that at the messaging layer as well. There's things like stake to contact for messaging. We've got some other features that, as we're bridging from sort of SMS to this crypto communications network, that we can deploy like a SMS reCAPTCHA. And so all of these different tools in their aggregate are really targeted at solving a lot of the spam problems, again, in novel and new ways that just aren't possible in the current world. We know that that spam is really a problem. And the other great thing is that the sky's the limit in terms of what is obtainable or sort of doable at the developer level. So I'm going to give you one more demo real quick of what Web3 enabled spam prevention can look like. So right now you can see that this user is enabling the customizable inbound call filtering, and this user now is going to go and make that call. it's going to say, hey, this person's got advanced call filtering enabled. If they're not on the network, it would just block the call already. But if that user does meet the requirements to call you, it will ring through. And you can see the usernames are popping up. It shows you some of those other verifications, like they've got a wallet balance, an ENS, all which is configurable by the user. So that's pretty incredible. One of the other things that we hear a lot about is the ability to just do native payments from a phone number to a phone number, right? These are the most ubiquitous communication identifiers that we have. And a lot of times users are required to sort of go to these separate apps. In the States, we have things like Venmo and things like Cash App and whatnot, and they're all predicated on using numbers, but there's no way to do direct to user or application to user payment methods. And again, as we transition those users into being Web3 first, all of those opportunities are enabled, really. And what's really the driving factor by that is because numbers in the Threnum world are mapped securely to a wallet address, you're able to do everything that you can do with crypto proxied by a user's number. So with that, I'm going to transition over to Chris to talk a little bit about the using CCIP for on-chain phone number lookups, as well as give a demo for that. So without further ado, I'm going to hand it off to Chris and we'll get it going.
Hello, everyone. My name is Chris Boscolo, founder of Threnum. I'm going to take a little bit of deeper dive in our under the covers of what our product does to look up secure phone numbers. Trust in the telephony infrastructure is one of the biggest problems, knowing who you're actually talking to. The way that we solve this with the Threnum protocol is we take the phone number that is a universal identifier used around the world, mint it as a blockchain asset, and then because it's a blockchain asset owned by an address, an EVM address in this case, we can use it to look up the asset with tools like Web3 name lookup. And that's what we're going to demonstrate today. So the project I'm going to walk us through today is actually a fork of the off-chain resolver that can be found in the ENS domains repository. After you fork it, just run yarn and yarn build in the top level directory. And once you do that, then you'll be set up to get to where I'm going to show you the rest of how everything works. The three things that I want to walk through today, I'm going to give a little bit of an overview of CCIP as I do this. But what we're going to talk about is the authoritative CCIP server, the thing that's actually giving the answers and signing those answers that the blockchain can then verify, or the blockchain contract can verify. The other thing that we're going to actually deploy as part of this project is the off-chain resolver itself. As I said, we're in the hard hat environment, so we're going to do everything in hard hat today, but it can just as easily be deployed to Intersect, testnet, or wherever. There's also a registry contract that's going to get deployed. This was needed to do the name lookups, but this is something that should already be present on each blockchain that we're using. And then there's a sample client app that we're going to dig into that's going to drive the demo as we go forward. Okay, so as I said, this dummy data that we're looking at here is a modified version of what's in the repo. I've changed the root name to just be root because this is just a demo. So you could make this anything you want. Well, you can't make it anything you want, but you want to pick a top level domain that is valid. Like a lot of people, if you're going to mirror it to DNS, it's got to be legal with a top DNS domain. It could be also just be AVAX or whatever. So to start the server, it's in the gateway directory, just yarn start. We're going to give it the private key. This is the testnet1 private key, so no problem showing that. Oh man, I accidentally killed off some of the JSON there, so I've cleaned that up. Okay, so now we've got our server started. The next thing I want to walk through is the hard hat setup. So first off, you'll notice here in the hard hat config that the gateway URL that's used to look up names is specified. This is the development gateway URL. But when we deploy for real, this will obviously be an actual DNS for a real web server that's doing the CCIP resolution. That's the most important part of the setup that we're going to talk about, at least in this demo. And so all right, so in the hard hat directory is just yarn start. The thing that I want to just draw our attention to here is you'll see that the registry, the ENS registry in this case, deployed at this address 0x5f. And that's going to be important in the next couple steps, because that's where we're going to point our client at when we do the client lookups. The other couple things I just want to walk through as part of this deployment that just happened here. So we just deployed a couple smart contracts. That happened via the 3 deploy scripts in the deploy directory here. This is the ENS registry deployment. Pretty straightforward. It's pretty vanilla. More importantly is the off-chain resolver itself. And I just want to call our attention to the 2 parameters that are passed into this contract. One is the gateway that's used to do the CCIP resolution, and then the address of the private key, the public address of the private key that's going to be signing the answers for these lookups. And so that's really important. And then the third part of the deploy steps is just doing some initialization. It's setting the root to root for the registry contract, and then it's registering e164.root here and setting its resolver to the off-chain resolver contract. And that's where the magic happens. And so the next thing we're going to look at is how a client actually does a name lookup. So to do that, before I dive into the code and demo side of things, let me just level set context. So what we're looking at here is this is the 3num app, and this is the messaging user interface on our app. And when you go to create a new message, you can actually start messaging someone using their phone number. And when you type in their phone number here, under the hood, we first do a lookup to see, is this an on-chain asset? And so when that call happens, now I'm going to switch back to this client to walk through how this is actually working. So the first step of that is the client takes the name and tries to determine what the resolver is for that name. That's just straightforward sort of ENS protocol or AVI protocol. They all do the same thing here. Any Web3, generally speaking, name lookup is going to work that way. Once we get the resolver, so we've got the off-chain resolver, what we're going to do is actually do a lookup on the address for that name. And so this is where the magic happens then. So we want to do a lookup, and in this case, I'm just going to make these names be what I'm doing in my demo. Top level could be ID, could be whatever. I made it root in the demo, so I just want to make it root here. So we do a lookup for phone number in E164 format. Again, just to take a quick step back, E164 is what you do when you want to dial somebody internationally on your mobile phone. You type +1 if you want to, excuse me, plus to then the international code. If you're in the North American region, it's 1, and then the phone number. So we drop the plus from the E164 because you can't start a name with a plus in ENS lookups. So we drop that, and then we tack on the E164.root. And in this case, e164.root is our off-chain resolver contract that's going to end up making the resolution for that. So what happens when we do the lookup to the off-chain resolver with that name, I'm going to walk through now to the actual smart contract, is the request to pull that name from the resolver ends up reverting. So equivalent, the equivalent of this transaction is not going to process. But what's really interesting about the way CCIP works is the revert has a bunch of data that the client is smart enough to pull out of the revert and take some steps with it. And the really important part of this is the call data. That's the name you were looking up. The off-chain resolver method that once you get an answer back from the web server, you need to call to prove that it was indeed signed by that web server. So this is a method selector here. And then the address of the encoded data, which again is the call data plus the address of the contract, resolver contract, so that the web server can be sure that this request is coming from the contract itself. The next step that happens, so that revert data ends up back in the client. The client parses that. And ends up calling the web server with all of that data. And I'm not going to walk through the server side code for that. But maybe I'll just look at a couple things really quickly. I'll just really briefly here. This is the code that the server uses to resolve this answer. And the important part of it is after it figures out what the data is for that name that it's going to return, the key part that we want to look at is this step here, which is to sign the results with the private key that was the private side of what was registered in the off-chain resolver when we deployed that contract. So if we come down here to our sample client, we'll see that there's a query set up. The registry address is the address that I showed you back when we deployed the contract, the actual address of the registry contract. And that's where we're going to send this actual lookup. And the last thing that happens after the server responds with that information is the client calls the resolve with proof method. And again, the resolve with proof method was passed as a selector in the revert method back on step 2. And so this allows the client to send in the response we got from the server, and the contract, the smart contract, the off-chain resolver smart contract, verifies that the signature is valid, and only if it's valid does it return the data back to the client. So from the client's perspective, the really important thing here is it's just using the ENS client resolver libraries. They've been built to be CCIP aware already, so no other changes need to be made to the clients that are doing the resolution of the names. But under the hood, there's a lot of magic that's happening. So that's CCIP in a nutshell and how to deploy the off-chain resolver. The other thing I just want to walk through really quickly, if this works, is not technically a live demo, but I'm treating it like one. So we'll see if it does indeed work. What I'm going to do is make make a few changes. to hard hat. So what we've done, I've already made these changes and I just stashed them in Git and just popped them out. So what we're looking at now is I've updated the URL that's set in the contract, so that it's now actually pointing to the 3num actual CCIP staging server. And the other thing that I'm going to show you is if you look at the off-chain resolver deploy step, I've changed instead of the hard hat signer address that we used to have, I put in this is the public key for our actual staging server. So now if start hard hat again. Oh, sorry, that's the server. What am I doing? So this redeployed hard hat. Now this time, the resolution, if I do this same command here, is going to hit the CCIP servers that are running in the 3num infrastructure. And you can see it's a little bit slower because it actually went out to the internet to do that. We are not returning the content and email records I only have the address record for this particular phone number registered, but you will see it actually did return the address record for this phone number. So this is a real world lookup of a real phone number that has been registered with 3num. Once I have this address for that phone number, I can now speak with that party, knowing it is definitely that party because they can sign their messages to me and they can sign whatever they send me. In our protocol, we do that setup as part of an encrypted end-to-end messaging, but many other things could get built on this. So that's CCIP use under the covers in the 3num protocol. Thank you so much. If you have any questions, we're going to be around during this session, so you can ask them. Have a great day.